Recording. Okay. So, hi everyone. Thank you so much for joining. We're really excited to have all of you here. This is our first event in the series of collaborations between Committee on the Environment and Urban Design Committee. And we also have two people from Jefferson University, College of Architecture, and the Built Environment. So I'm going to advance the slide if it lets me. There we go. So it looks like you can just click. So this is a CES approved course. Everyone with an AIA number, please upload, well, actually in the chat, if you could tell us your name, full name, first name and last name, and your AIA number, we will make sure that you can get credits for attending tonight. So please start doing that. I'm not going to read this slide because we'll get into this with the presentation. This is also part of that. I want to say special thank you to Jacobs for sponsoring this event. We're very excited to be a supporter of a very important topic. And now, Danielle, would you like to speak?
Hi, everyone. I'm Danielle Fleischman. I'm co-chair of the Committee on the Environment. And I just wanted to step in and say that COTE's Environmental Justice Subcommittee and the Urban Design Committee began this year with a consensus that climate action and its impacts on our communities is a growing concern, often overshadowed by the events of the world and the privilege of many. The challenges of the present don't fit into simple categories with easy fixes. They're often entangled and require solutions to address them in tandem. And this way we can truly implement change that's lasting. And we can increase our chances of success by collaborating with others, by educating others on the issues at hand and potential paths forward. So as Sophia mentioned earlier, we've come together to highlight 3 aligned topics that deserve more attention: urban heat island, redlining, and gentrification. So tonight is the first of 3-part collaborative series that's going to highlight these issues at a local level. So keep an eye out for our 2 upcoming sessions focusing on specific neighborhoods in Philadelphia. And as she also said, to kick off this series, we're pleased to have 2 students from Thomas Jefferson University College of Architecture and the Built Environment presenting their Urban Heat Island project.
Thanks, Danielle. And now we're going to introduce our 2 speakers. Elizabeth May is currently a 5th-year Bachelor of Architecture student graduating in May. She'll be continuing her studies at Thomas Jefferson University in the fall for a master's in urban design. Elizabeth is passionate about environmental justice and finding innovative ways to design. Victoria Martin is currently a 5th-year Bachelor of Architecture student graduating in May. After graduation, she'll be working for Jacobs, yay, and will be continuing her studies at Thomas Jefferson University for a master's in geodesign in the fall of 2022. Victoria is passionate about social equity and resilient design practices. And on to you guys.
First, we wanted to thank the Sophia.
Please stay tuned for some technical difficulties. Your laptop locked.
Oh, no. Sorry, everyone. Still figuring this out. Oops. Like. Sorry, guys. Is there another laptop we could use for this? Sorry, guys.
Do you want Sophia?
Yeah, that would be great. Or Alice, do you have the presentation on your laptop? Yeah, I think because it's kind of big, so I can't email it, unfortunately. I'm sorry, guys. Bear with us. I didn't know it would do that.
It's weird.
All right, so should I just like unplug it and? What is this doing anything?
I
Do you
think
need
that's
this?
for the clicker, right?
Yes, that's for the slide advancer. For this.
Go. Plug it in. Note to self, check battery settings next time.
Okay.
Oh, is it up?
Should be. So sorry, let me just get this open for you. Here you go.
Thank you. Okay, so now that we're back, we wanted to thank the professors who have helped us through this project. So starting off, I had an independent study last spring with Carroll Herman, and then last semester and this semester, we've been working with Tatiana Swenda, and then our professor for the class that this project was done for, Professor Peng Du. So our project is a case study into the heat vulnerable neighborhoods of Philadelphia. We are, this project was to use the scripts that we learned during environmental performance modeling class and find some way to use these scripts. So we, based off of the research that I had already started, we wanted to find neighborhoods in Philadelphia and see if using these scripts, we could work through and start to see some change and see if using parametric design is the way of the future and the way of learning how to design more equitable neighborhoods. Yep. Just careful. Let's not press buttons.
Let's not press buttons. Oh boy, I'm sorry, I pushed it. Okay, great. So to begin the presentation, we'll be talking about what the urban heat island effect is, and I know many of us probably are familiar with it, but it's essentially the phenomenon that happens within cities that results in higher temperatures within the city as opposed to outlying areas surrounding the city. And this is largely due to the sheer volume of structures that we have located within cities, high-density housing, high-density buildings, as well as impervious surfaces. So they sort of absorb and then trap the heat, as opposed to natural landscapes that do not retain the heat, and they're able to cool down the environment much, much more than an impervious surfaces often will. So essentially what we've found through our research during the course is that daytime temperatures within cities that are experiencing urban heat island effect are typically 1 to 7 degrees higher than the current condition that's happening outside of the city. And then that correlates to roughly 2 to 5 degrees in the evening, nighttime temperatures. Oh, it's not working. Okay, so this is a map. No, the GIF's not playing. So this is a map that was showing temperature trends, annual trends between the year 1979 and 2019. And essentially, this map was showing the Earth's temperature, average climate temperatures increasing over the course of these years. Climate change is happening. Temperatures, as we see globally, are getting hotter and increasing. Essentially, we started to understand as us as designers how we can start to make interventions to start to alleviate some of the results from climate change. So some environmental implications that we came across through our research is understanding that with climate change comes consequences, right? So we have increased energy consumption. So for example, the use of heating and cooling of buildings. We have elevated emissions of air pollution and greenhouse gases. We are seeing impaired water quality, impacts in aquatics and other types of wildlife, and we're expected to experience more droughts and heat waves as global temperatures continue to rise. There we go. So this is looking at a heat wave that from 2019 of the United States, showing the temperature changes throughout Memorial Day weekend. And essentially, the map is showing the increased temperatures that are happening over the course of the time frame that's largely affecting, you can see here in the southeast, these temperature changes are rising and can be very stressful on the environment, but not only the environment of us individuals and the communities that live within these areas.
So some of the health implications of the climate change and the temperatures being hotter are heat stroke, and so you start to get issues such as cramps, heat exhaustion, heat stroke, hyperthermia, premature death, and that is one of the factors that as we come to talk further on, we talked about life expectancy in the neighborhoods of Philadelphia. And so our question to start this project was, how can we improve design to mitigate heat vulnerability? So going through to start this project, we found a lot of indicators that indicate vulnerable neighborhoods. So impervious surfaces and hardscapes, lack of tree canopy and vegetation, median household income, and the hotter outdoor temperatures were the main the main vulnerability indicators that we used for our analysis. But as you can see, there's so many more other effects of, or other vulnerability indicators. So this is showing a picture of two of the neighborhoods in Philadelphia. One we chose was a neighborhood that was in, as we get further in to the presentation, in the cooler parts, which is Roxborough, and then we have Kensington, which is one of the hotter parts, and you can just see how the neighborhoods are constructed different and how all of those indicators that we just looked at are just shown prevalently in these images. And this ties back to the redlining practices of the 1930s and 1940s. This map shows the redlining map of Philadelphia. It is where the neighborhoods were based as desirable or undesirable to loan money to by the Homeowners Loan or Coalition. And so the best areas were the areas that people were more willing to loan money to. And then the hazardous areas were neighborhoods that were hazardous to loan money to, and most of it was based off of race because of all of the other social factors during that time period. The racial breakdown came to be where the hazardous neighborhoods were mainly populated by Black residents and people of color, while the best neighborhoods were populated by professional white men living in these areas. So our focus for analysis, we chose Philadelphia because, one, we're part of the greater Philadelphia community at this point. Living in Philadelphia for 5 years, we've become very connected to the city. It is a city affected by urban heat island, and the conditions vary greatly between neighborhoods, so you can cross one street and see a completely different neighborhood very drastically, very quickly. And we wanted to address the lingering effects from redlining.
So for identifying our study area, we sort of blended, for this project, we blended GIS tools with Grasshopper and various Grasshopper plugins in order to create this project. So for the GIS tools, we went through a series of analysis to be able to identify a study area and identify a neighborhood we wanted to focus. So for our first point, we were focusing on heat exposure. So this is a map that was created by the Philadelphia Department of Public Health and the Office of Sustainability. This is depicting summertime temperatures that they averaged from 2013 to 2015, and showing the degree difference within those areas relative to the overall city temperature as a whole. So as you can see, when we refer to the cool areas, they're the areas depicted in this deeper blue or purple shade. And when we refer to areas being of the hottest, we're referring to the areas of the red and orange shades. And you can see that the temperature differs vastly. Some areas are 14 degrees cooler than the city's average temperature, while other areas can exceed essentially 8 degrees. So that's what we first looked at and analyzed. And then based off of this analysis, we've identified neighborhoods that we thought were the most heat exposed because of the temperature difference. And these are the neighborhoods, 21 neighborhoods that we've identified as being the most vulnerable towards heat exposure. We then wanted to analyze median household income, and we thought this was important because more heat exposure equates to more heat stress, meaning that the individuals living within these areas would be expected to pay more towards the cooling of their buildings and cooling of their homes. So we wanted to analyze income to see, to identify the most heat vulnerable neighborhoods, and this is why we used income as an indicator. Then going from there, we were just doing the analysis of race or ethnicity within these neighborhoods, and we decided to use this as a factor, more so analyzing and looking at relating it back to the lingering effects of redlining and to see if the individuals who are within these areas and within these neighborhoods to see what the demographic composition of the community is. We then decided to look at life expectancy as part of our research. Heat exposure, heat stress, and heat vulnerability often has health implications, whether it's mental health or physical health. So we wanted to analyze the life expectancy within the areas of Philadelphia. So we were looking at the average life expectancy by zip code, and we've eliminated neighborhoods that either weren't listed for life expectancies or had higher life expectancies. And then we were looking at green space and tree canopy because vegetation is a great way to naturally cool. in areas that are cooler within Philadelphia are typically along riversides or have abundance of tree canopies. So we wanted to start to find the most heat vulnerable neighborhoods. So we did a rough analysis looking at the amount of tree coverage and green space within these neighborhoods.
So after doing all of that analysis, we came with the two conclusions, and we chose the two neighborhoods, the TIOGA neighborhood and Carroll Park. And we chose those two neighborhoods because they were on opposite sides of the river, and it gave two different dynamics that have the same issue. They're in two very different parts because, as you can see in this last slide, you have a clump of the neighborhoods around TIOGA, and we wanted to have our two case studies still be separate a little bit. So those are the two neighborhoods that we selected. So then we wanted to bring in basically a baseline or something, one to look at that is in quote unquote the best scenario. So it would be one of the cooler neighborhoods. So we chose Chestnut Hill as the cooler, and then looking at this map, you see the both neighborhoods that we chose ended up being in the hazardous and definitely declining areas of the redlining map from the 1930s and 40s. So going off of demographics, we have I think the biggest indicator looking at this map is the median household income, and how with Chestnut Hill, you're in the six-figure category, and as you go down, you start to have much lower median household incomes, and while the population rises in those neighborhoods, and the demographics, you have mostly people of color in TIOGA and Carroll Park, while Chestnut Hill, it's less than the other two. So after doing all of that analysis, we then zoomed in to each neighborhood, and we started to try to run the analysis on the larger neighborhood itself, and it was starting to get too overwhelming. The data was just getting to be too much, so we chose about a 3-block square from each. And we found those because as we got zoomed into the map more, we looked and we found where all of those points that we talked about, the vulnerability indicators, really overlapped in all of them. So we chose these 3 blocks. So this is that zoomed in a little bit more. And then this is just an overall street view of what each of those blocks looks like. And as you can tell, each one has its own different view, but at the same time, Carroll Park and TIOGA, you can see how there's less street trees, less green space, less tree coverage in general. So this is where we really chose our neighborhoods and made those decisions. So through the methods of analysis, we used, as Victoria said, we used ArcGIS Pro, and then going into Rhino 6, in Grasshopper, we used Ladybug, Honeybee, and Dragonfly to be able to do daylighting analysis, find the extreme hot weeks, calculate UTCI, and using all of the data that we were able to get from the weather data that is provided through the airports. We used the Philadelphia Airport, the Philadelphia International Airport, and then we established a microclimate for each neighborhood to really see and zoom in and see what happens in those neighborhoods temperature-wise.
And then for our analysis period, so since our heat exposure map was focusing on the hottest temperatures on average during the summer, we also, through our scripting, identified the hottest week within our neighborhoods that we were determined based off of our Grasshopper script. We were given this information, so we ran our analysis looking at that week, and then we further narrowed it down between the hours of 10 a.m. and 4 p.m. We found that the first time we ran this analysis, without setting the time frame, it was averaging in overnight temperatures and late in the evening temperatures, which was drastically lowering our results, and we wanted to focus on what we thought would be the hottest point during those days. In order to better depict the thermal comfort, which is what we're referring to as the UTCI, within these neighborhoods. So UTCI, or the Universal Thermal Climate Index, is describing human comfort relative to thermal conditions. So it takes into account humidity, the wind, solar radiation, any kind of indicator or anything that would directly impact our ability to be comfortable within a space or an environment. And we were then able to take this information, and it was measurable through heat stress. And then heat stress is similar in the fact that it's about human comfort and how heat affects us. So through our script, we were able to actually, as Liz has mentioned, determine a microclimate. So once we created this microclimate, which was specific to our neighborhoods and more accurately depict the temperatures within these neighborhoods, we then wanted to identify the heat stress conditions within these neighborhoods. So as part of our script, we were analyzing UTCI. We were looking for heat stress, strong heat stress, and extreme heat stress throughout our script. So we were analyzing the data that came in through our UTCI between 89.6 degrees to 114.8 degrees. And then we further also recorded temperatures that went beyond the 104.8 degrees so that it would reflect the strong heat stress, very strong heat stress, and the extreme heat stress. Again, referring back to us as individuals and how that the temperatures would affect us. So this is what our existing versus proposed conditions look like. So this is zooming in on the neighborhood scale again. So as part of our script, we created the existing conditions. We averaged what the tree coverage was looking like within the neighborhoods, our grass coverage, temperatures during the hottest week. So that's important to remember because it's not 100 degrees every day in these neighborhoods. This is during the hottest weeks over the summer. And we've identified strong heat stress, the value being 75 hours, excuse me. And then for our proposed conditions, so we went in and as designers, we intervened in increasing tree coverage, increasing grass coverage, and to see if we could get the conditions within these neighborhoods to lower or be to equal similar conditions that you would find within a cooler neighborhood or a cooler part of Philadelphia. And then this is looking at the direct sun hours. So we chose to do this, again, speaking to the individuals living within these communities. So you can start to understand and start to feel what it would be like with being within these spaces. So you can see through our interventions of grass coverage, tree coverage, that we were able to lower the hours of direct sunlight, which in turn was able to lower the thermal conditions and the conditions that would impact us and the individuals within these communities. And then we did the same analysis looking at the streets. Again, these lots are primarily impervious surfaces, so we were trying to do interventions. And then we also wanted to reflect that on the street as well, since impervious surfaces are a contributor towards the heat island effect.
And so this is the analysis that was run in the TIOGA neighborhood. From this, we learned that to even make a notch of a difference in a degree, so this is about 0.3 degrees less between the existing and proposed, and 3 hours of strong heat stress less, we had to increase the tree coverage by 3 times. We had to multiply that by 3 times, and the grass coverage by 12. So it's something that on this micro scale we found is really hard to model, and it's hard to really zoom in on this scale because there's so many outside factors going into this one area that trying to change in one little 3-block area is harder to do. But with the analysis, we were able to see that adding in trees and green space and green roofs, we were able to lower the direct sun hours by 5 hours, and that's on the lots, and then this is on the streets. We were able to lower it by 8 hours. And then this is the analysis for the cool neighborhood, which is Chestnut Hill. We were able to, we did not do any proposed because this is a neighborhood that we weren't intervening in. It was something that we already, it was our baseline. So the tree coverage is 65%, the grass coverage is 39%, the temperature being 100.92 degrees Fahrenheit, and the hours of strong heat stress was baselined at 75. So the average sun hours on the lots was 12 hours, and the average direct sun hours on the street was 25 hours. And so that just really showed what we wanted to see for this analysis.
So this is an overview looking at what all 3 neighborhood existing conditions look like. So as you can see, Carroll Park and Tioga, the neighborhoods that we've identified as being most heat vulnerable, do have a higher temperature as opposed to Chestnut Hill. And the goal of this project and the goal of this case study was to see what interventions that we could do within the community to get a similar condition within the neighborhoods that we've identified as being heat vulnerable. And then these are our proposed conditions now. So increasing tree coverage, increasing grass coverage, and we got fairly close with the temperatures. And this was, and we put in quite a lot of tree canopy. We've dramatically increased the tree canopy as well as grass coverage within these neighborhoods in order to start to get comparable temperatures that you would see in Chestnut Hill. And then again, looking at the lots comparison between what was existing versus what's proposed. So you can see as we flip between the two, the amount of tree canopy coverage that we had to add to these neighborhoods to be able to get a comparable result compared to Chestnut Hill. Now, even though we were intervening and dramatically increased the tree coverage, it's important to know that these neighborhoods still do have higher average direct sun hours that are hitting the lots at specific points.
So in conclusion, we ran all of this analysis. We really dived into the research, really trying to find a way to work through all of this. And we realized that doing this at such a small scale, a 3-block scale, is it's not, it's effective, but at the same time, we need to grow and it needs to start to expand more and more and more so that at this micro scale, it is changing a little bit, but as it starts to grow into this macro scale and starting to get into the larger neighborhoods, there should be starting to be a drastic change in the temperature. Our plans for the future is that Victoria plans to do an independent study in her master's degree, working and analyzing more, and we hope to continue this together. And she wants to analyze current energy efficiency of buildings, increase energy performance of buildings, and looking at how this can be done within economic reasons, and so that it's economically sound for the people in these neighborhoods and it's not going in and changing too much all at once. And then I've discussed working on this as my thesis in my master's and starting to go into the communities that are affected by these vulnerability indicators and talking to them and seeing what they have to offer on choices that they want to see, and educate them more about the heat vulnerability of Philadelphia and work through all of that together. So that is where we want to go with this so that we can continue this research and really see what can be done using these tools that we've been given. And we just wanted to say thank you. And the QR code on the screen shows or brings you to the website that goes through all of this information that we just presented to you. You can scroll through, there's interactive maps, there's sliders where you can see the proposed and existing, going back and forth to kind of work through. So.
Our contact information is also at the end of this story map, our email addresses. So if anybody is interested in aiding or perhaps continuing the conversation that we're having here today, please feel free to reach out to us directly through that email.
Thank you.
I'm just going to come up real quick.
Yep.
And, no, you guys are staying here. We have a question from the virtual audience. Oh, we're going to open it up for questions for you guys too, if anyone has questions for our lovely presenters. So Susan Christian from Germantown asks, do you have data on deaths by heat stress?
Right. So for this project, we put this project together roughly. Quick short answer is no, we don't have the direct data. But for this project, we put this project together in roughly a month and a half from start to finish. So we had to quickly be aware of a ton of different topics in order to be informed when creating the basis, or we see this more as like the skeleton of what a larger project can become. We do know that heat stress, individuals impacted by heat stress, there are higher mortality rates related to that. I don't know the specific data off the top of my head, so I'm not even going to pretend for a second and give a statistic that I'm unaware of. But that statistic is higher than what we would expect to see today, which is unfortunate.
Anything to add?
We did a little bit of research, and we did find that it does affect people of older age, people living alone, and people of lower socioeconomic status. That's where the heat stroke and the heat vulnerability really lives in those neighborhoods, and people people of those demographics are the more affected ones.
Right, and those are the indicators that the City of Philadelphia currently use and acknowledge in order to identify what they're calling heat-sensitive populations. So we took a similar route to what the city currently has done research for and acknowledged, but we also wanted to change the indicators slightly to see how that would impact what we've identified as most heat-vulnerable neighborhoods.
Great answer. We have another question from Farzad Hashemi. Thanks for the great work and presentation. Could you please elaborate on the sources for building properties, such as materials, albedo, window-to-wall ratio, and et cetera? How you collected these data for the existing building and fed to the model? Thanks.
Yeah, so a lot of it was going into Google Street View and looking at some of the ages of the neighborhood and looking at some of the houses. That was a really long question. Let me try and bring it up here.
I mean, just to bounce off of that, so if you go to our story map, at the bottom of the story map, we've provided images of all the scripts that we utilized, and as part of our script, we had to code or tag buildings as a certain class in order to be able to run the simulation and the analysis, and based off of that class, it generated that information for us, and we were able to use that information to generalize the building types within the neighborhood. Again, just for clarification again, so this project came about in the course of a semester. So during one semester, we learned how to use scripts, what scripts are, how to use the programs, and how we can take all the information that we've learned over the course of the semester, modify the scripts, and use it so that we can create a meaningful project for us. So in the case of the buildings in particular, we did use the building information that was generated as part of those tags that we used for the script in order to run this analysis and create this project.
And before we go to a second comment from Susan Christian, I wanted to see if there were any questions or comments from the audience. Yes.
Yeah, terrific presentation and methodology, and it was just so clear. One thing, a little surprised at the temperature difference. Wasn't that great between the three communities? A fraction of a degree, which of course can still make for more discomfort and all. Were you surprised by that? Expect to see a
Do you want to see
bigger
it?
range of temperature difference.
Repeat the question first.
Oh, do you want?
Yeah, so the question was, were we surprised by the small temperature change between the three neighborhoods in the end? And I think we were at first, but then we started to realize that because it was at such a zoomed in scale, that it wasn't necessarily capturing the full neighborhood in and of itself. So I think once we start to broaden the neighborhood a little bit more and start to get like some larger green spaces involved and some of the other outside factors, it could change the temperature. But I mean, some of the things like one temperature can change a drastic thing.
Yeah, so as part of our research, yeah, we've identified that 1 degree Celsius, or like, I think the average was between like 1 and 9 degree change for Fahrenheit, can start to show environmental impacts, so start to impact aquatic life, start to disrupt ecosystems, but that could also be the tipping point for when individuals experience heat stress. So although our results were minute, that's not completely unexpected because we did pick the hottest and most extreme condition to analyze within the city. So that's why those temperatures are high, and that's why there is such a small change, because I guess the point of this is that although we did dramatically increase the tree canopy within many of the neighborhoods, there's only so much trees that we can put in there to start to reduce climate change, because, you know, with such a large scale, putting a couple trees at a micro block level, like what Liz was talking about, can only do so much. So that's why we need to start looking at, well, how can we start to look at building systems? How can we start to look at energy performance to also aid in relieving the individuals within these areas for the thermal comfort?
And then there's one final comment from Susan Christian. I mean, I think you kind of spoke to this already a little. She says, it seems like the intervention neighborhoods, you would have to lower the temperature by more than 1 degree because people of lower income have less ability to use fans and air conditioning. Likely in Chestnut Hill, 100-degree temperatures aren't as impactful as 100-degree days in TIOGA.
Yeah, and one of the other things that we looked at and did some research on was that people in the hotter neighborhoods have to then use more air conditioning, more fans if they have access to them, and then by doing that, the air conditionings then put hot air out into the neighborhood, which then creates the temperatures being hotter and hotter. So it's a cyclical effect of making your own neighborhood hotter because of, like, you need the air conditioning to cool yourselves down. So it's this give and take, and it's a very like dynamic subject in trying to figure out exactly how to do that. And that's why in the future we want to look more into more passive strategies or more economically feasible ways for people to have access to these or air conditioning and fans and other things like that.
Right, and actually the next question from Chitsanzo Isaac to everyone. Thank you for your wonderful presentation and hard work in your research. Did you happen to identify other passive interventions besides canopy cover and softscapes? Perhaps this could be something to look into your further studies of the topic.
Yeah, so that's actually a great question, because we would like to enhance this project and really do a deeper research and deeper analysis into how we're able to intervene within the neighborhoods. Liz spoke earlier in the presentation about making meaningful interventions and interventions that the neighborhoods want to see. And for this project, we were limited, of course, by the time frame and the scope of the course in order to present. So we did stick with the tree canopy and coverage as our main intervention points in order to do this analysis. But in the future, we hope to be able to start to look at passive interventions and being able to do a deeper scope on and research of what that means and what that's going to look like within these neighborhoods.
Great. Any other questions? No, they've answered everything. They've solved it. All right, great. Thank you so much, everyone, for coming. And thank you so much, Elizabeth and Victoria, for presenting. This was wonderful. I learned a lot. And we really hope that you join us for the other series lectures. So please keep an eye out for COTE and Urban Design Committee series lectures in the future. All right, now conclude.
Thank you.
Thank you.
How do we stop the recording? It's here somewhere. Stop,
Yes, just click it.
stop.
There you go.
And then stop recording.
There's, yeah, the stop sign.